section 7.1b a little bit, but then also into section 7.2, okay? So that's where we're headed. We remember that we did this activity where we decided to, you told me how many siblings you have, right? You told me that. In our study, or what we were looking at, we said, suppose that this average number of siblings was for all of our AP statistics students, okay? Now, with that being said, with this specific problem, what is the population? Max and Matthew, let's make sure we're here, okay? What would be the population for this up here?
The number of siblings.
Yeah, I think we said this. Number of siblings for all AP stats, 5th period, right? Awesome. Okay, so I'll leave that there. What is the parameter we're searching for? Yeah, average number of siblings, y'all rock. Okay? Alright, so we've got this, which is perfect. Now, question. If we were to take a sample of everyone within this AP Stats group team, okay, and we ended up taking a sample size of 4, what is the sample?
4.
Yeah.
4 people selected. I like it. 4 people selected. Alright?
Yeah.
I was like, huh?
Pretty much the same, right? What is the statistic being used?
The number of siblings, or just the samples, or however big the population
The sample, we call it X bar. Nice. Okay? Max, Matthew, let's put those down, please. Come on, guys. X bar would be up there, okay? The parameter we call mu. Okay? Parameter we call mu. Now, with that being said, we've already started this, but some of you haven't done it quite yet. That's why you have dots out there. So here's what I'd like for you to do. 2 things, okay? The first thing is, if you haven't done so, you're going to put the number of siblings up here, okay? So you're going to put the number of siblings that you have up here. I'll calculate the true mean, which is mu, okay? I'll calculate that. But then also, I want you to do a second thing, and I want you to randomly select 4 people within this class, and I want you to find how many siblings they have. And then based on that, you're going to average that together, and that's going to be your one sample, okay? Each person is going to do that within this room. When you find that, whatever the average is, you're going to take that dot, you're going to put it wherever it's at. You could have like 2.4, that's possible. You're going to put that, or 2.5 would be possible. You're going to put that dot there, and then we're going to see what happens to this down on the bottom, okay? Now, based upon this, what do we call above my hand? What do we call that?
Dot 1.
Population.
It's a dot, Max. It's a
Random.
dot.
Population distribution.
That is a population distribution, because what is a population? Our whole class, right? Now, some of you are missing up here because you missed yesterday, so you'll need to put your dot up here. But overall, once we get everyone up here, that's the population distribution. What would be this?
Sampling distribution.
A sampling distribution, right? Does that make sense? Okay. All right, if you missed yesterday, we'll kind of get you tuned in on that. But we want to put our dot here and then randomly select here. Here's how we'll do it. Max, how many siblings do you have? Just throw them out there.
1.
1? Great.
1.
Okay. Morgan? 2. Emily?
0.
2.
No, she
No,
said
0.
0.
Oh, 0, my fault. I can't hear it, my fault. Matthew, got you?
2.
2? Gabby?
She's not here.
She's not here, so what we'll do, this sounds really bad, but we're going to cross her out, okay? And that sounds really bad. I didn't mean that. But we'll just cross her out because we need that. We can't have her be in this. Campbell?
One. Tell her that you cut her.
No, I didn't mean that, Gabby. I did not mean that, Gabby. Okay?
1.
Okay? Got Campbell there. Gary?
0.
0. Got Maddie?
3.
Mary Martha?
3.
V?
1.
James?
1.
Matthew?
1.
Ella?
1.
And Michael.
0.
Okay. So here's the deal. When you do this, how do we take a random sample of these? Wes.
Gabby
Wes, I'm going to put you here,
Gabby
okay?
must have had 3.
Wait, I think Gabby has 3.
Gabby must have had 3 because that was another 3.
Gabby
up
had
there.
3?
Because there's
Or
3
2.
up
We have
there.
put 3 twos up there.
Okay,
That's
so we'll
supposed to
do-
be 1.
Oh, it was 1.5.
1.5 is supposed to be a 1.
This is true. Okay, so we'll just say Gabby had 3. Okay, so we won't erase her. Gabby, we're not erasing you. Hold up. We don't want to erase her. There you go. Okay, so 3's there. We're going to put Wes at the top. Wes, how many? 0. Okay, so here's how this works. Question. Okay, question on this. How do we do a random sample of these of 4? How could I do that?
Pick your 3 best friends.
Maddie, go ahead.
Could you assign each person a number? 1 through 4?
each person a number and then use the random digit.
The dang table
Like
D.
find four of them.
Perfect. And we don't have table D on us right now unless you have your formula sheet.
Calculator.
So you could do your calculator, right? How could I do my calculator? That's right. You're right. How could I do my calculator?
Random number generator.
Random number generator or random, what'd you say?
SRS.
SRS or rand int, right? Integer. And then we total up the amount. We'll start Wes is 1, Max 2, Grant 3, all the way down. Okay? All the way down. And then we're going to have a group of 4. Now, does anyone have questions on that?
No.
So 2 things you're going to do. If you've not put one up here, make sure you put one up here just so we can see the population. Do the random sample, take a dot, put the average number of the 4 on there, okay? The amount of siblings there. Put it here, okay? And then afterwards, we don't have to record the number of siblings. We've already done this over here. So then, down below, this will be our sampling distribution, and you can just copy what you see up here. That make sense?
Mhm.
All right, couple minutes. Ready? Go. You do it. You do it. Good to have y'all back that were here from the Operation Christmas Traveler. Welcome home. Did everyone put one on the population up here that missed?
The random number.
How many are in there? Random in here.
But what's
Yeah, what's the math?
Regardless.
Zero.
Because you're trying to find.
You do math and then you do Yeah,
I thought you used numbers for like.
There's 20 we took out. There's 16. I put in 20 in there now.
Someone got 1/2 here?
That was me. That was my mean, yeah.
Gotcha. That's impressive.
I got 0, 1, 1, 0.
1, 0.
Hey Campbell, could you do me a favor?
What's up?
Because I messed up. Could you just average these together to get what mu is? The true population means?
1, 1, 1, 0. 3, 4.
Okay, that's weird.
What did you get?
3 siblings.
It's just gonna be 16, or 20 divided by 16.
This should
You
show
get a
up.
full sibling.
1.25.
Yeah, that's
1.25?
Yeah, 1 1/4.
You didn't call it.
No, it's kind of a little off. The
Yeah.
way that I had it,
Oh, that one?
it's exactly the way
Yeah,
that
mine
it
can
worked.
do that. But
It's gotta be by
yeah, you
quarters.
just put in.
That was my
Oh,
fault.
no, you don't like math?
1.75?
Yeah, I know. I'm
Is that
telling
right?
you how to do it.
1.75.
1.25.
25.
Random interval.
What?
Here we are.
Yeah.
Would it lower be
That's
1 or lower?
Lowers 1, comma,
Who has 3 siblings? Gabby does?
and then your upper,
Maddie
your
does,
upper
Mary
is
Martha.
16,
I do.
and then comma, and you
Mary
want
Martha, you
comma
do.
4.
I'm right in the middle, and I'm the only girl.
Really? I did not know that.
Yeah.
Do you like that or?
I mean, I always wanted to share clothes with someone, but for some reason I bet my sisters do like these.
So is Wesley number 1?
Yeah,
Okay.
You
sure.
0. Are you 1?
That's how you assign the numbers, James.
Alright, bro.
Yeah, bro, assign your numbers, bro. Coach Jay, I taught Makai some post moves last class at
Did you?
PTA.
I'm glad. He needs it.
He comes up to me and he goes, "Hey, I need you to teach me some post moves."
Really?
Your post moves were really good whenever we played. I really need you to teach me some. He goes, "I didn't expect to play center this year, so I need to learn some moves."
He kind of plays it right now before Chris is there.
What the?
Oh, yeah.
What?
Because y'all's only other center is Sean, other than that.
Yep, right now.
Yeah, that's what I'm saying. So he kind of has to.
Not sure.
Gabby's here.
This makes me mad.
Thanks, Jerry. Thank you. Jerry, here, he dropped something.
So,
Check their work out.
What do you do after you? What's happening?
What do you mean up there?
Last one.
I mean, good. I'm a.
We're really, we're getting really close to the meeting, Stan.
That's not a meeting.
Yeah, we are. Almost
I'm
You put 6 right in the middle.
I was not very close.
Paul put in
Not
6.
very close.
I was.
You weren't in my class.
Oh, really?
Walk out
Hey,
there.
honest,
attention,
honest
kid.
pre-cal. Yeah, I do now. An honest pre-cal, I just put it in and I quit. And I sucked and I failed the meeting
Walk out there 64 He put 6 right in the middle instead of
What?
He put 6 numbers all over the middle by 6.
That makes sense.
All right, does everyone have one up here?
Yeah.
Hey, can you copy this down? This is important right here. If you could copy this down on your sampling distribution, the population distribution isn't, well, I guess you could put that up here. This is more the population distribution.
Yeah.
And comparing, okay, kind of comparing the population to
That is
the,
100%.
sampling.
I have to actually study
Okay.
like actions.
4 again. 2 + 2 5.
all right, so here's what I want to talk about, okay?
I can't.
Wong, what were
Oh,
the
we did.
ones that you got? Were they all 3?
Because I missed it.
What'd you get?
Yeah, my
There's
brother.
3 of the 3s.
He tried to say it's not an answer.
14 is 1.
And so he
2 is 1. 14 is
You know, so what were you saying?
1
I believe that.
So you have 0.75 reserves.
I don't care. I mean, as long as you're giving better grades, I'm not doing that.
Okay. Hey, could I do this while you write that down? We'll just have a discussion real quick. I think we're gonna switch this one, am I right?
He didn't put his.
Let me clap it.
Oh, you did not. Who got 3? Did you randomly select
Possible.
Yes.
4 3s?
We had.
No,
Okay.
four threes, and then because I
Seven
You had to put 7 twice.
I
Hey, this
started doing-
and this might be my fault here, okay? This is my fault because I should have described this here. In our study, this is a good question. Once I choose one, do they go back into the pile?
No.
No.
They don't, right?
That
They
makes
don't.
sense.
Does that affect what
That
might
affects
happen up here?
all of ours,
Okay.
yeah.
And that's my fault. Okay, that's my fault on this. But just trust me, we'll kind of talk through this together, and I think based on that, then we can go from there. Okay. All right. So that might impact some of these numbers a little bit. We know that mu is 1.25. So question: based upon that information, by the way we sampled, would you say that this is bias? Yes or no? Is X bar, because that would be what the mean is of the sampling distribution, right? Is X bar going to be approximately the same as the true mu or true mean? I would say it's approximately. I would say that it has low bias, if any at all. So we would say that in this instance, 1.25, which would be this is where mu really is right here. That's a pretty good approximation of our mean, I would say. Okay, so that's a good job. So I would say that this has low bias. Now, this might be a little tweaked based on what I thought would happen, because I wasn't specific enough. That's my bad. Does this have low or high variability?
Looks like it's got.
I would say it has high variability, but it was because of what we did, right?
Yeah.
That's how we did it. So I would say this has high variability, but if we did it the right way, trust me, it probably would have much lower, shorter variability. So I would say traditionally this probably would have low variability. Okay? So question. Okay? This is where we're headed today. This is why it's important. Okay? We've got 10 minutes before we break. Okay? So we're gonna hit this hard for 10 minutes because I got some breaks set up in between. When I look at this right here, the population distribution, is that a normal distribution? Why?
Yeah.
Because it has,
Mayor Martha, go ahead.
is it because it's not like so much?
I would say it's not symmetrical. That's true.
It was 60, 95,
68, 95, 99.7, we call that the empirical rule, right? Okay, that's true. Based on the fact that we just look at it, and does it look like a normal distribution? It doesn't, right? So we would say that in this instance, the population distribution is not symmetric, therefore it is not a normal distribution. But a unique thing happens, and we'll look at this later today. The more samples we take, of the population distribution, even though this is not a normal distribution, I'll call it ND for right now, not normal distribution, look what happens to this. And again, if we did it right, I think it would even look better. What is it starting to do? Starting to slope, and it's starting to go to the mean of what the true value is here. How do you think we could get it to where it looked more normal?
Way more, so that should
More.
be normal.
More samples. Does that make
And
sense?
don't replace the number.
Because guess what would happen, and I'll show you here, if we did more samples, I'll just put it as a dot, what would happen is we'd still have some out here, but the more we do, it would actually come closer and closer to what my true mean would be, and we could actually use a normal distribution if we had enough samples that we had there. Now, how do we know how much is enough or not enough? We're going to look at that today. But does that make sense how a population distribution may not be normal? But if we take enough sampling distributions and it doesn't have high bias and high variability, we can actually use it and use a normal distribution from this. Okay? Does that make sense?
Yeah.
Kind of, sort of? Okay. With that being said, let's fill in a couple of these things. Did y'all get that down over there? I think we did over
I
there.
have a question.
Yes, go ahead. Ella.
So, if the population is not discrete, it's continuous, it may be a normal distribution.
Correct. What we're saying is that in a population, it's possible to have a normal distribution here, but it's also like we see here, this is not a normal distribution.
So this is just a special case.
No, there's a lot of population distributions that aren't normal, right? But what we're saying, Ella, is if I took a sampling distribution from this like we just did, the more samples that we use from it, even though this is not normal, this ends up turning into a normal distribution if we have more and more and more samples from it. Here's a question: which is more variable, population? Which has higher variability, the population or the sampling distribution? I've got them here.
Population.
Okay.
Yeah, I
Explain.
understand
Explain Campbell, because you haven't had to take it yet. Oh, you have. Never mind. Someone else explain. James.
Oh, yeah, I can explain it. I don't.
Thank you.
Why does this Why does this have higher variability than down here? Why do you think? What do you think we did that would take that into account? Wes.
We allow decimal places because it's more,
It's an average.
Continuous.
Yeah.
it's
It,
continuous rather than being, I forget the proper term for it.
Discrete.
that's really good. Both of you, nicely done. That's good teamwork there. So when we take this, we're taking an average of 4, right? Think about it. That means my lowest and highest value is now being averaged together. What's naturally going to happen?
It's
gonna
Things are going to
shrink,
come
yeah.
shrink in. Now, this right here was not V's fault. This was my fault because I messed up, okay? But this would, if we didn't have that, it would come in together where it would have, you will want to put this, sampling distributions have lower variability. That's key. Lower variability than population, okay? If you're good, say uh-huh. All right, awesome. Let's keep going. This is going to be fast notes, okay? We recorded the mean up here. Actually, I messed up. That other one should have been population. The sampling distribution should have been down here. So hopefully you have both so you could kind of compare. The big note that we want to make sure we kind of hit on, okay, so we've done this. We took this. You recorded your mean already up here. You were good. We said this. Does the sampling distribution display bias? No. So we'll put no there because the mean, why? Because the mean
Low variability.
is equal to x bar, meaning my true mean is equal to the mean of my sampling distribution. Okay? Hopefully this is making sense here. Okay? Does the sampling distribution display high variability? We said ours did or did not. Sometimes it's hard to know what they mean by high variability depending on context. So we're just going to put maybe because it depends on the context there. Okay? Campbell.
So is mu projected and x bar actual? Or like
Flip-flop those. Flip-flop those.
mu is the actual and x bar is the projected?
Correct. When we say projected, we would say if we did a bunch of samples over the course of time, what happens to x bar and mu?
They come in, yeah, they get really
They
close.
get really close to each other. And we would say that especially if we do it the right way. Now for
Right.
me, that's
Yeah.
probably an example of not to do it for me. Okay? But that's how we do it. The mu would get closer to x bar if there's low bias. And then if there's low
So
bias.
x
that's
bar
it.
is your projected.
X bar is your I want to be careful on projected.
What's a better word?
When we do a sampling
Expected,
distribution,
expected.
that would be, I don't want to say expected, that would be, I want to be careful on those words. What we're saying here is that X bar, if we did a sampling distribution, the mean of my samples of each of those 4, right?
So it's the actual.
Actual's mu.
Actual mu.
This is my population, that's mu.
Alright,
Got me?
what's X bar?
X bar would be the average of my samples. I like that. That's better.
Alright.
Someone want to say that differently?
The average of your samples, wouldn't that just be I mean, I get that they're the same thing because they're both mean, but how
Correct.
you said it just sounded the same.
So this is the mean. When I do a population distribution, that's all of the individuals in my population. This is the average of those, right? But when
Alright.
I take samples of size 4, in this case, and I put them up here, right? The middle ground, or the average of those sampling distributions, would be what we call X bar. Because X bar relates to what? A sample. Mu relates to a population.
Alright.
So mu is the average of the population, X bar is the average of the sample.
You said that perfectly. That's exactly right. So I want to be careful on expected value. Expected
Alright,
value is
so
like last chapter
that's why I
probability
had, yeah,
distribution. There. And I want to look into that so I can define it a little bit better, but does that make sense?
Sister.
All right. Question. This is for 3 tickets right here. First person to stand up. Is the above dot plot, the one that's over there on the bottom right, is that a true sampling distribution? And then you got to explain why.
Yeah, you take it.
I'm gonna say no, because even though we did it random, not everybody in the class, there's a chance that not everybody's in the class was used.
I'm going to give you 1 on that because that's true, but I want the explanation. It's no, but why? Maddie.
Oh wait, never mind.
Matthew, go ahead.
A true sampling distribution would include every set of 4 students,
Oh, that's
every
true.
selection of 4 students. So
Is that possible in here?
I mean, it's possible, but it would take a long time to get every single combination.
Every single combination. So we don't, I understand this is, so you would say no, because a true sampling distribution, and I'll get the word down, is we need to find X bar, we need to find X bar for every possible group of 4, okay? Group of 4. Does that make sense? We still will call it a sampling distribution, but technicality says you would have to do all of them, and I want to make sure you're careful of that, okay? So the definition is a statistic is the distribution of values taken by the statistic in all possible what? What do you go here?
Outliers.
What are outcomes?
Results.
What did we just take?
Yeah.
Samples. Yeah. So of all possible samples of the same what?
Population.
Of the same. How many? So each time you selected it, how many did you choose?
4.
4. So it has to be the same
Same.
size, right? You couldn't do 4, 5, 6. You have to all have the same one when we do that. And from the same, this is where you come
Population.
population. You rock. Good. Okay.